recorded, both what's typed there and the audio and whatever presentations we make. We can decide by the end of it whether if this has been an anodyne enough meeting that we can save it, or if it's been terribly contentious and we want to edit it. That's really up to us down the road. But do keep in mind that this is being recorded, and it's certainly valuable for us as a way to generate our summary for the meeting in DC that's coming up in a month's time. But it might also be valuable if it could be put on the web verbatim for folks who could not attend and may have an interest in the outcome of this. So I will take a little query at the end of the meeting to see whether there's any deep objections to just putting this material on the IRIS, UNAVCO website, whoever website it would end up at. So, all right, so that's all the administration. I'd like to welcome you all to this webinar. Its official title is Evolving Landscapes and Global Environmental Change. I sent around a couple of links, the National Academy Future or Emerging Challenges in Earth Sciences or something like that, and then the Grand Challenges document from IRIS. But I'm sure most of you have sort of a fairly good idea in your own heads on what you'd like to do. I'm going to spend maybe 3 or 4 minutes summarizing myself and Eric Kirby's presentations at the last IRIS meeting at the Sun River Resort, Sunset Resort in Oregon, that was held a few months ago. And then kind of lay out the groundwork of where this is going and how this is going to feed into the meeting that's coming up in May in Leesburg, Virginia. As I said at the beginning, and there's been a few more people who have joined, please just go ahead and type your name into that name and affiliation and what your interest, whether you're in cryosphere or hydrology, into that box, and then after I finish my introduction and before I throw it over to Ramon, I'll just read off who's here, and that way you all know who's here. So Andy, do I have this now?
Yep, I am going to send you the screen sharing. It should pop up on your screen in just a moment.
Yeah. So let me see if I can, okay, there we go. So you all should be seeing a beautiful landscape here that Eric stole from the web somewhere. Mountains with glaciers coming down through there, and this is Eric's take on interactions between climate, hydrology, surface processes, and tectonics. The ultimate goal of this exercise that we're going to is to provide input to the meeting that is coming up, which is called Future Seismic and Geodetic Facility Needs in Geosciences. As I'm sure all of you are aware, there is a couple of wonderful facilities, very focused facilities for doing seismic and GPS, well, geodetic work and magnetotelluric work. Those are sort of the 3 instruments. The science that those instruments can facilitate, here's one example of it. So Eric's take on it would be that those facilities can really help and bring new insights into how, for example, hydrology, which is something that one of the organizers who couldn't be here, Jay, will talk about, or surface processes, which Ramon will talk about in a minute here. So some of the themes are feedbacks among and between climate, erosion, and evolution of the surface, and more particularly and more directly, how deep mantle flow might actually have impacts on dynamic topography on the surface. So this is one example. A second one that he put forward was whether you can see ice and water moving over the surface. How much is moving and whether it's changing. A beautiful example of that was stuff that Victor Sy and Meredith did in Greenland, where they could see using the global seismic network how glaciers were changing their flow speeds and patterns over time in Greenland. So and that was something that certainly the geodetic network was, or the seismic network was never designed to look at. Well, in going forward, we ought to see whether we can actually use the seismic network for our own, and GPS network for our own use. Here's what the TA and the US array networks. Wonderful signs coming out of it. Some of it expected, some of it unexpected. This is the picture as it looked. I think they're marching through Pennsylvania even as we speak. And so the example that Eric wanted to highlight was, well, can we use these data to tell us something about what where the shorelines are or were based on are emerging a new picture of what the subsurface might look like. So sort of remarkable things that were unexpected, and I would argue that our communities, the cryosphere community, the hydrology community, are ones that are really poised to take advantage of these remarkable changes that are coming up. Because Ramon has to run, I'm actually going to throw it over to him to give us another set of particular examples. And before I do that, Ramon, if it's all right with you, I'm just going to read off who's here. Is that okay?
Yeah, that's fine.
Okay. Let's see. I need my mouse back. Karin Fisher from Brown, Bill Herbert from, I'm not quite sure, Brad Lipovsky, Stanford, Rob Woodley from IRIS, Gene Sauber from NASA, Paul Winberry from Central Washington, Cryosphere, Luciana Astiz, NSF, Dave Simpson, Seismology, Jeff Freimiller from UAF Tectonics, Hydrologic Loading and Glacial Isostatics, Bob Dietrich, IRIS, Ann Meltzer from Lehigh Seismology, from the Pascal Instrumentation Center, Ken Anderson, Paul, Tim, Dean, Noel, Howard, Panina, and Katie Liz, Lorraine Huang from UCD CIG from computational modeling, Kathleen Hodgkinson, sorry, Kathleen, UNAVCO Geodesy, Megan from UNAVCO, Megan Miller from UNAVCO, Justin Sweet, and is that everybody?
I'm on
sorry, I'm sorry, there's still some more. Katrin Hafner from IRIS, and Bill Herbert from University. I knew that. Sorry, Bill, from University of Pittsburgh. Okay, so let me go ahead and clean the
muted.
You have
unmuted.
Sorry?
There was a brief muting, but I think everything's fine now.
Okay, all right, we're back online here. In maybe a few minutes, I'll give Karin a chance to also weigh in if there's any sort of overall questions or comments that she has. In the meantime, I'm going to jump over here to, there's Kirby, there's Natalia, and there's Ramon. Ramon, are you online?
Yeah, can you hear me?
Okay, yep, I can hear you. So just tell me when to go to the next slide, and I'll do that.
Okay, this actually is maybe the second or third one, so maybe go to the beginning.
Yep.
So yeah, thanks everyone for the chance to talk with you. And you know, I'm kind of speaking today more about research opportunities in tectonic geomorphology, which is area of my main research, and so I'm not really speaking that much on behalf of EarthScope, but certainly we can think of how great the EarthScope science has been coming from the great observatories, and kind of take that going forward as a organizing sort of concept as we move into this next stage of planning. But I was asked to talk more about tectonic geomorphology. So The big infrastructure needs are are topography, geochronology, climate information, and simulation. So my own work has been a lot in terms of topography, is working with Open Topography, which is a facility supported by NSF instrumentation facilities, but also tightly coupled with UNAVCO and National Center for Airborne Laser Mapping. I think geochronology is really going to be a critical thing going forward because, you know, there's the sort of maybe cliche, but, you know, no dates, no rates, and we need rates to understand process. And there's been a lot of technological kind of improvement in geochronology in the last decade or so. Also, you know, we have improved ability to observe the climate and weather across the globe from a number of different perspectives, and this is a critical part of you know, how the landscape evolves. And then I think increasing coupling with simulation and ability to build intuition through coupled sort of geodynamic and surface process modeling. So just maybe a couple slides going forward. Sridhar.
Okay.
So this next one is just pulling, these are questions that are in two of the community studies that were shared as part of the planning activity. So the first one was Landscapes on the Edge, which was a National Research Council kind of study on the Earth's surface processes. And so these are a number of questions that come up. How do geopatterns on the Earth's surface process arise, and what do they tell us about process? How do landscapes influence and record climate and tectonics? What are the transport laws that govern the evolution of the Earth's surface? One I added just because I think it bridges also to many of the faulting-related questions that other groups will be covering, is how best can we retrieve the record of paleo-earthquakes from the landscape? And then these other ones are sort of echoing those earlier questions that come from the NROs, from the New Research Opportunities in the Earth Sciences. So I won't read them, but they also echo what was in Eric Kirby's comments. So next one, Sridhar. So at the large spatial scale, there's a lot of interest in understanding interaction between climate, erosion, tectonics at these large spatial scales, at orogenic scales, and big questions about the balance or lack thereof between kind of tectonic influx and erosional efflux, and how that might be manifest in terms of landscape response and topographic form. Next slide. So at finer spatial scales, this one's kind of jammed up. There it is. So this would not be at the orogenic scale, but more at the kind of kilometer and even down to the meter scale, is the opportunity to characterize that fine scale interaction between tectonic or especially earthquake processes and surface processes. So this one slide shows, you know, mapping active fault traces, reconstructing landscapes that are offset or deformed by repeated earthquakes, and then the landscape response to uplift. Next slide. So it's a little bit of a delay, but oh, there it is. So one of the things that's really important and a huge opportunity going forward is our ability to measure topography and then remeasure it. And so this kind of four-dimensional landscape change or topographic differencing, this is a paper came out a couple years ago where we had topographic data before and after the El Mayor Cucupa earthquake, and the difference between those two topographic data sets gave this really spectacular displacement field from along the rupture, and it showed both the discrete deformation along the faults but also the distributed deformation between them. And so this is a big opportunity going forward that will require significant infrastructure support. And then maybe one more slide. Yeah, so and then one final point just on the topography and measuring the environment, and this is just for structure, but you can imagine doing this with seismic wave fields, with ionospheric or atmospheric sensing. Is this, you know, kind of crowdsourcing or ubiquitous data gathering from, you know, sort of both coordinated as well as kind of haphazard opportunities. And so us finding ways to integrate these big data streams that come from commercial and other sources and integrate them to go after science questions is, I think, a big opportunity where infrastructure will be needed, both the kind of observational as well as the cyber infrastructure. So those are just a couple thoughts, maybe kind of random. Hopefully I'll do a better job when I give my talk, but I wanted to just share those, and I'll toss the ball back to you, Sridhar.
Okay, thank you, Ramon. That actually was very helpful, and in particular, what I'd like you to think about, and all of your colleagues in your community, and all of those of us in the cryosphere or anywhere else, is a question of scale, resolution, accuracy. So you showed examples that ranged from, as you said, the meter level up to sort of a few kilometers or hundreds of kilometers, and this is a facility, future needs for the facility, and the more clear we can be on the required accuracies and the required scales and the required resolutions, the more helpful that will be for the final synthesis of this. And so I'd encourage all of you who are giving presentations today or will be giving them later on to try to come up with some of those numbers. And they don't have to be the right numbers, but they should be in the right ballpark.
Right.
So thank you, Ramon. Okay, let's see how we're doing here. As I said, if you have comments or questions, please type them into this box here, and I'll be able to speak them out to the rest of the community. Karin just reminded me to encourage folks to send white papers in to the website, or submit them on the website before April 15th, and then those would all come in as input to the workshop. And these white papers don't have to be extensive. I think one figure from a recent paper of yours and a paragraph or two that goes along to explain them, and perhaps has, as I said, a couple of points on what your future needs might be and what scale of numbers those would be. That would actually be very helpful, and the more of those we can collect, the better a picture we can make of what the future Pascal UNAVCO or IRIS UNAVCO facility ought to look like.
And I just want to add in that deadline actually got extended to the 27th of April, the end of the day on Monday, so to give people a little bit more time.
Okay. And the meeting itself is, I think by now the invitations have gone out, and I don't know if there are any slots left over. I'll let the organizers speak to that. Okay, we're going to jump forward here a little bit, and Natalia Gomez will be at McGill soon, is currently at NYU, and I will let her go ahead and present her 3 or 4 slides that she has. And I'm going to play those. Natalia, are you on?
Yeah, can you hear me?
Yes, I can hear you well.
Great. Thanks, Peter. So this is just going to be sort of a work in progress of the things that I'm trying to refine and answer some of the questions that you brought up about scale and things. But this will just be sort of a review of where I'm at now in terms of preparing for the talk later. So this is going to be questions about glacial isostatic adjustment and sea level. So I'm a sea level modeler. And so I'm going to start by sort of introducing what's happening on the modeling side and what data would be useful for that. So if you can, the slide. Okay, so modeling sea level and ice sheet histories and glacial isostatic adjustment requires knowledge of sort of two out of three of the following, which is ice distribution through time, sea level history, and then the Earth's response to that ice and ocean loading, surface loading. So in other words, we need to know the rheology and structure of the Earth. And so in the past, typical GIA models would sort of infer ice distribution through tuning to available ice age sea level data sets. But a recent sort of development in this type of modeling is the development of coupled ice sheet sea level models. So that means a sea level model coupled to a dynamic ice sheet model, so that we can predict dynamic ice sheet changes as well as sea level histories at the same time. And we can also predict the interactions between these two. So it's been shown that sea level changes feed back onto the ice sheet dynamics themselves, and so there's an interaction between these two systems. So as an ice sheet retreats, gravitational and deformational effects lead to a sea level fall in the vicinity of a retreating ice sheet, and this sea level fall at the grounding line feeds back onto the grounding line evolution and sort of has a stabilizing influence on that ice sheet retreat. So progress in being able to model these two things together is helpful. So yeah, if you can advance to the next slide. So of course, the degree to which this sea level feedback is effective in stabilizing an ice sheet depends on the response. Is there a picture of on the left, top left?
No, there isn't.
Ah, okay. Well, there is on my screen. Okay, I can just sort of talk through what that is then. Right, so changes in viscoelastic structure of the Earth will, of course, change the sea level response, and so this will change predictions of surface deformation and sea level change, which we measure in two different ways. First, by sort of directly altering the timing and geometry of deformation in response to surface loading, and then second, through this sea level feedback, changing the timing and extent of ice sheet retreat, which in turn feeds back onto Earth deformation and sea level change. So the figure that is not showing right now is just a plot of seismic tomography over Antarctica. So Antarctica is an important region for looking at future sea level change, and it's also, unfortunately, an area where the challenges that arise in this type of modeling are sort of the worst case scenario. So we have current changes in rapid changes in ice sheets, ice history going on. We've had past deglacial changes, and the structure of the Earth beneath the Antarctic is highly variable. So we have a really low viscosity area in the West Antarctic, and then a much higher viscosity and thicker lithosphere in the east. And depending on what scale of modeling study that you're looking at, you may get very low viscosity in a very localized study, and then higher in a lower resolution, broader area study. And all of these in the West Antarctic show much lower viscosities than you would assume if you looked on a global scale. So what would be very useful is high-resolution knowledge of lithospheric thickness and mantle viscosity in Antarctica, and in particular focused on those areas, marine-based areas that are changing now or expected to change in the future, so that we can incorporate the effects of Earth deformation and sea level changes onto future ice sheet retreat. Other sort of things that could be useful on a more global scale in terms of glacial isostatic adjustment, there was a Bifrost sort of Scandinavian high resolution GPS that in North America could be a really useful thing to think about. And if we advance to the next slide. So now looking more at global sea level and more recent and future changes. So measuring sea level changes is tricky in that measurements are all contaminated by glacial isostatic adjustment effects from past changes, ocean dynamics, and then of course ice contribution to sea level changes. And separating these and understanding the different measurements can be really difficult. So on the right is a prediction of just the sea level change following collapse of the West Antarctic ice sheet. So it's just a normalized sea level pattern. So the sea level pattern is geographically variable, and the largest signal that you see is this large sea level fall local to the area of melting. So currently we have tide gauges and GPS sort of distributed around coastlines around the world, but what would be particularly useful is to increase the amount of instrumentation in this region where the largest signal occurs, so near or on Greenland and near the Antarctic or smaller mountain glaciers. So sea level, there are different types of sea level measurements that measure different quantities. So tide gauges are measuring water depth. And then you have GPS measurements that are measuring crustal motion, so the land deformation, and altimetry, which is measuring sea surface height. And each of these different types of measurements comes with its own sets of problems. And what would be useful in future is being able to work with multiple types of data to help solve some of the problems of one type of data with another, and also co-locating measurements. So having a tide gauge in the same location as a GPS measurement could be very useful in helping to separate some of the contributions to each of these data sets. So bottom pressure gauges are not currently, they're sort of recently being developed. They could be very useful in measuring sea level in that tide gauges are restricted to coastlines, but bottom pressure gauges you can put in the middle of the ocean. And also they eliminate some of the dynamical effects that they just measure the mass changes above them. And so this can eliminate some of the other contributing effects to sea level changes. So more bottom pressure gauges and maybe improved bottom pressure measuring devices. So there's an issue with drift. So working on that would be really useful. Other ideas that came up in discussions with others were GPS stations with sort of an ocean view in order to measure sea level. In other words, measure the distance between the sea surface height and that GPS station, and sort of looking at what we can get out of existing and future satellite data. So I understand probably launching another satellite is not an option, but there are sort of ways to look deeper into what you can get out of the existing data that we have. So maybe techniques of processing and things. And just to talk, since there was a mention of topography, for coastal zone sort of sea level rise hazard, looking at that issue, high resolution coastal topography would be a very useful tool for that as well. So that's all that I had. Great.
Okay, thank you, Natalia. That actually was really sort of thought-provoking in that it points out that usually we measure things where things are happening, and in fact we ought to be looking possibly globally and just collecting data as the US Array quite nicely has done, marching right across the continent. Well, we need to expand some of these things globally and think innovatively about some of the other measurements. We don't want to get in this workshop in DC. We don't want to get bogged down in details of instrumentation. because as soon as you do that, eventually we'll just start talking about batteries. It always happens that we end up talking about batteries. But I think if we keep it at a high level, saying what kind of scientific measurements do we need to have made and at what resolution and what accuracy, we'll let the engineers see if that's a feasible and a viable goal or not. Okay, let's see. There's been a few comments. Let me just see if I can read some of those off or respond to them. Let's see. Let's see. Yeah, so Karin does mention that the way you can have input if you haven't don't have a slot for the actual meeting is to participate in these webinars and to provide a white paper, and your input will be taken into account at that point. Okay, so I'm gonna now move on and sort of very broadly we have hydrology, surface processes and landscapes and geomorphology. We have sea level and GIA, which in this case are combined together. They don't have to be glacial isostatic adjustments and sea level, and then cryosphere. These are sort of the broad categories into which I've tried to divide up, and if people have a different grouping, they're certainly welcome to throw in a white paper or throw a question out now. And then hazards, which was a point that Natalia made that I think was not made in Eric's talk or in Ramon's, and I think we ought to keep our eye on hazards as a contribution that this facility could really speak to, not just traditional. What I'd call traditional IRIS hazard work, which is earthquakes, but the landscape evolution and hazards or sea level hazards, those kinds of things. I'm going to take the next couple of minutes here to talk about the cryosphere. I don't think Helen is on. Is she on?
Helen is on.
Okay.
Yeah.
Helen, can you hear me? And if you would, if you'd like to say a few words, you can. I'm certainly happy to let you. The organizers or the presenters in the plenary session are Jay Famiglietti from Irvine, Helen Fricker from UCSD, Scripps, Natalia from McGill/NYU, and Ramon from Arizona State. So I've asked them to, and then Eric gave a little bit. I have a little bit here. Helen, do you have anything that you'd like to throw in here?
Yeah, I haven't prepared any slides, but actually what you've got there is exactly what I was planning to say. Long-term observations. You must have read my mind. So I was actually going to throw up the time series from the ice shelf paper that we had a couple of weeks ago in Science, and really the reason for doing that is to show that over that 18-year period where we were looking over the ice shelves with radar altimetry, there is an incredible amount of interannual and then interdecadal variability on all of the ice shelves all around Antarctica. It's not like at all a simple case of you go in and observe for a couple of months and you get the answer. You really need to be there making continuous long-term measurements. So I know that's a real challenge for in situ measurements, but it's just a way to be thinking about it. And also, as you said after Natalia's talk, yeah, we really do need to be looking at the places that are not just the places that are changing, because the places that are not changing have also got very interesting signals that we need to understand about what's happening on the ice sheet. So I know I didn't really give any introduction, but basically, mainly one of the things we're looking at is changes in the elevation of the ice sheets, the grounded ice and also on the floating ice over long time periods. And one thing that we were really, really short of when we were doing that study, which is from 1994 to 2012, is just there's hardly any validation data at all. There's just no in situ data to compare the satellite data with. So it's just something to think about in the future as these new missions are being planned and on the books, that we should be also thinking about what kind of data sets we should be collecting on the ground to support these incredible satellite data sets that we've got. I can elaborate a little bit if you want. Or, does anyone have any questions? Or
I don't, as Andy said, people can't really pipe up, I don't think. They have to type their questions in, so please type them in if you do have questions. Maybe the elaboration that you could talk a little bit about is surface elevation data pretty much it, or are there other? I mean, yeah.
No, not at all.
Go ahead.
Actually, I mean, just talking about that particular work, it was elevation data, but of course, velocities. The horizontal information that comes from GPS is also vital, because we can't assume that we get a snapshot in, say, 2005 and another snapshot in 2012, and we can't assume that if you're looking at differences in velocities over those two sort of epochs, that's not really a good. We need to have continuous observations of velocity because it changes. It's not. We know about the stick slip on Willans. We know that there's tidally modulated ice velocity. We can't just be looking at a snapshot all the time. So this continuous measurement thing is also for the horizontal motion as well on the ice sheet, and that's a critical thing because if the ice motion, the speed of the ice changes, and that's changing the delivery of ice to the oceans, and that's affecting sea level rise. So actually, I think I definitely want to coordinate a little bit with Natalia before the meeting to make sure that we're not repeating ourselves and that we kind of complement each other as well in what we say.
Yeah, that sounds good.
There's a couple of questions, and one is how you would define long-term, and that's actually an excellent question, and one that you can either think about now or for the meeting. Is it decades or is it years? And I'm sure it matters.
How long is a piece? How long is a piece of string? I mean, really, Duncan Wingham always said for the last probably more than a decade that you need at least a decade of measurements over the ice sheet to really understand the changes, and I think that's still right. I mean, if you don't have, ISAT was a laser altimeter mission. I don't know how much background to give on all this stuff, but we looked from 2003 to 2009 with ISAT, NASA's laser altimeter satellite, and some of the trends that we observed over that short time period, so 6 years, were actually very misleading, because if you look over the longer term, you can see that we really were just aliasing things that were happening on longer time scales, really. So, for example, Totten Glacier, which has actually been in the news lately, if you look over the longer term, so say 2 decades is a really good number, I guess. Anything on the order of sort of 15, 20 years is good. We could actually see that overall the elevation on the thickness of the Totten Glacier has actually not changed considerably over that long-term period. But if you look just at the ISAT period from 2003 to 2009, there is a definite decrease in elevation. So if you only look at that time, you're going to see an artificial loss. But over the long term, it's not doing that. And so, yeah, you do need at least a decade, I would say. I think that's still a really good number. And so, these campaign-style GPS programs that we're all doing and all involved in, it's just, to me, it's just tragic that we have to take them out after 4 or 5 years, because just leave them in as long as we can would be the best thing.
Yeah, no, that's but that is a wonderful segue to another question, which is when do you need these data? In the U.S. with EarthScope or with US Array or the transportable array, those data are available immediately, which is which I think has been enormously helpful for students and researchers to use in classrooms and education, and obviously in research as well. Just because it's now. As soon as an earthquake happens somewhere, folks immediately run to the IRIS website, the USGS website, and pull up some gorgeous examples that can be used. So is that's something that folks who are writing these white papers, doing their presentation, should speak to. How important is the time between when the data are collected and when they're made available to the community and to the public?
I think that's a really good point. I think that having telemetered data is absolutely great. Cryosat-2, for example, this is a radar altimeter that's up now. It's a European Space Agency mission. Their data are becoming available within 4 to 6 weeks of being acquired, which is just fantastic, because you can really see things that have just happened, and that's on the ice sheet these days. That's really important.
Yeah, yeah. The link that I would sort of like to make between the cryosphere, and unfortunately we've had a couple or 3 cryosphere things in a row, and that sort of reflects the bias of mine, but there is a link between what we're doing and what some of the quote traditional earthquake seismologists in this community might want to want out of this facility. This is a plot that you don't have to look at in any great detail. All it is a seismic moment along the horizontal axis and duration of slip along the vertical axis. And this is, I think, one of the truly extraordinary outcomes of the last decade has been the recognition of slow slips, the combining of seismic and GPS data to try and explain them, and not fully doing that. People are still working very hard at that. And right in the middle of this, there's a couple of stars, a red star that says Glacier and a red star on the right side that says Glacier, because the cryospheric community is starting to recognize that so many of our processes actually link to the to the earthquake and sort of solid earth tectonics community, because we have earthquakes. They span the range from regular earthquakes, the lower right. Does my mouse move? No, it doesn't. The lower right trend to the slow earthquakes, the sort of central upper trend, and they span the range from seismic to obviously glaciers span the range from seismic to aseismic deformation, from lower to upper parts of this graph. So there is a very strong, a very direct link between the cryosphere and the solid earth tectonics and geophysics and geodynamics community, and those are the kinds of links that we really need to be making to justify what is going to be I think a large and enduring investment on the part of NSF, we hope. So I think the more that you can think about crossing boundaries from your community over to some other communities, and how the facility can provide resources or data that makes that possible, I think the better off, the better the outcome of this upcoming workshop. Let's see. Looking forward, again, this is polar centric, but the very last bullet there is my link to the outside world. We expand our networks and polar broadband networks, broadband seismic networks and arrays. That helps Natalia. That helps Natalia measure or estimate what the properties of the mantle are, so that she can do her modeling more effectively. Improve instrumentation for polar deployments. That helps Helen get data through the through the year. US Array is wonderful. You go, you plug in somebody's backyard, you have data, you have telemetry. Not possible in some parts of the world, and so instrumentation for long-term deployments is something. Active source imaging, I haven't really talked about that, but that's something that I'm very interested in. And then glaciers as laboratories for understanding fault processes. As I showed in the preceding plot, there are lots and lots of links that can be made across boundaries. Let's see. There's a couple of questions. Could someone speak, this is from Bob Dietrich, could someone speak to the potential role of seismic and other geophysical techniques, for example, electromagnetics, in imaging shallow structure to study critical zone and related processes, and what sort of facilities are needed? That's an excellent question, Bob, and if Eric Kirby had been here, and he sends his apologies for not being able to, he had a wonderful slide. Where was it? Yeah, so let's see, is it this? Nope, not that one, sorry. There we go. Okay. So this is a recent paper talking about erosion rates and looking at steepness, channel morphology. These are the kinds of measurements that, shallow surface measurements that can be made with better imaging, better some of these very novel and innovative ways of looking at surface flow using seismic data. It's unbelievable. You can actually see how much water is flowing by looking at the noise in the seismic network. You can look at how much water there is in the near surface using the GPS network. This is stuff that Christine has done at Colorado. It's just remarkable. So there was that, and there was one more plot that he had that had critters in it. There we go. But to get anything funded, you need critters in it. And so here's there's a bunch of these critical zone observatories, and understanding rock fracture, how rocks in the near subsurface are breaking and changing and allowing for fluids to flow downwards and for organisms to exploit it. We've got one of those CZOs right up the street from us here in central Pennsylvania, and that's another area where geophysicists, geochemists, and biologists could certainly collaborate very effectively. And so if there are folks out there who are listening who work on that interface, please send in white papers that pull that out in greater detail than I possibly could. Let's see. There's another question here from Jeff Reimuller. What is the geographic scope envisioned for the workshop? North America plus environs, fully global. Gosh. I would say I'll give my opinion, and then I will let others type in their opinion. I think it is a global problem, and Natalia's graph was wonderfully indicative of that. We cannot solve problems by putting networks in North America. We can't solve problems of interest and importance to our community and to society by just putting instruments in North America. So my take is around the world. Let's see if we have any other opinions. Jeff, if you have sort of a follow-on on that, you think differently that we should be focused, please feel free to throw in a white paper saying that. Karin says fully global exclamation exclamation, or is there only one exclamation there? I don't know. Thank you. How are we doing on time? We have a few more minutes, and I'd like to, as a run-up to this meeting in DC or in Leesburg, what Karin suggested to me was that we should be thinking about the science that we need to do and not either how it's going to be funded or how it's going to be organized or how it's going to be facilitated. What the outcome of this meeting is at one step up from what you might write in a proposal to NSF. It is how sort of the importance of your science and the types of data that you need and the and how different those data will be 5 or 10 years from now than what they are today. That's the time scale that I'm using, 5 or 10 years. I don't know if we should be looking at a longer one. I certainly can't think beyond the next few years. So if people have a crystal ball and they can look farther down, then that's fine. But how do you envision what kinds of data should the facilities be providing over the next decade or so? If you think they're providing exactly the right data at exactly the right scale, that's fine. If you think there needs to be changes, then that's fine too, and that's what should come out, rather than any kind of nuts and bolts discussion of where the facility should be, how they should be managed, how they should be organized. That's something that is really for a different discussion. Any more questions, comments? Trying to see who else is on here.
Sridhar, I have a question about sort of how big to think as someone presenting what the science needs. So I guess what is a reasonable thing to ask for, if that?
Yeah, that's a really good question.
So, so some of the things like involving global sea level that might not fall under the umbrella of UNAVCO or the other, what is possible?
Yeah, so this workshop is put together under the sort of broad umbrella of IRIS, UNAVCO, and a few other geophysical techniques. Nevertheless, I think if you can make the case that there are data either available and usable by or useful to you that are not part of these sort of facilities, well, make the case and say it would be better for them to be brought in rather than folks to have to go out and look for them, or there should be some facilitation of it or something like that. If it involves a brand new satellite being launched, well, as I said, I don't know that that's going to happen, but I'm a little bit pessimistic about that. I will say that UNAVCO does have a lot of satellite data. The WinSAR working group there has been very successful at collecting together and archiving a whole bunch of images for the Western U.S. and increasingly for globally. So those data are available, and the more we can use that and the more we can justify that, the better off we'll be. Karen says it would still be good for people to convey the principles important to the facilities, e.g. the importance of community governance, responsiveness to changing science. That is an excellent point. If people do have, so this I think was is a comment related to what I said earlier about moving up one level from the proposal. We still need to make sure that we endorse the sort of broad principle that the science community has to be fundamentally engaged and in control of how the the directions that the facilities are going. Without that, we got nothing. And we do have that now, and we need to hold on to that. That's a very good point, Karen. Thank you. Okay, we're right at 3:30. I think it's been, I hope it's been informative for folks, and I hope that you all can throw in your white papers and think a little bit more extensively about what you would want out of this workshop that's coming up in just about a month's time. Let's see, we have a couple more comments. UNAVCO provides lots of data that complements satellite altimetry, GRACE, and other measurements of sea level and cryosphere change. GRACE alone does not determine ice mass change without GPS on bedrock. Yeah, that's an excellent point. You need to complement the GRACE data because obviously mantle flow is also changing the gravity. And then we have one more comment from Bill Herbert at Pitt that he thinks it's been a useful webinar. So this, I think there's no reason not to archive this webinar and to have it available for folks that would like to use it. The main outcome that I would like out of this is if y'all could send in a white paper that has your interesting science, interesting measurements, a little bit forward-looking, and what scales and what resolutions. Seasonal monsoon loading. Yep, that's right. Okay, thank you, everybody. Are there any more comments, questions? If not, I'm going to throw it back to Andy for any comments that he has. Andy?
All right, thanks, Sridhar. I'm going to hit end on the recording and get it buffered up, and I should have it, unless there are any objections, email me if there's any issue with me doing this, but I'll put it on the Sage Engage Workshop Facilities webinar page probably by the end of the day.
Great. Thanks,
all right,
everybody. Thanks, Natalia. Thanks, Helen. Thanks, Ramon.
Yeah, thanks, everyone. Take care.
Thanks.
Okay.